Hello class, welcome to today's class. We are looking at basic principles of cartography by me, my humble self, Mary Liu Marcellinus, the cartographic lecturer. From the previous class, we look at map scale. So, what is map scale? Or let's start by this. What is map? Maps are graphical representation of pictures that are drawn to scale. Remember in the previous class I said that you may define it in your own word, but the key word map scale or drawn to scale must be there. So any map without a scale is not a map, it's a figure. So maps are graphical representation of pictures of the earth surface that are drawn to scale. Then what is scale? Scale is a relationship between map distance and the actual ground distance. It's a relationship. It marries the two together, the map distance and the ground distance. That is scale. The map, as I said earlier, without a scale is not a map. It is a figure. So you should note that. Then there are three types of scale. We have three types of scale. We have the statement scale, we have the bar or linear scale, we have the representative fraction. The statement scale, example of it is 1 centimeter represents 1 kilometer or 1 meter or 1 mile. Then the bar scale, for bar scale or linear scale, we have two division. It is of two division. From the 0 to your right hand is the primary division. From the 0 to the left side is the secondary division. Then we have representative fraction, which is 1 ratio 50,000 or 1 ratio 100,000 or 2 ratio 100,000 as the case may be. Now note that to convert centimeter to kilometer is by dividing by 100,000. You divide it by 100,000. Then if you are converting to meter, you divide it by 1,000. And to mile, it is by 0.621. So take note. Uses of scale, or you may say functions of scale. 1. Distance measurement. Distance measurement. Scale allows you to measure the distance from point A to point B to its real world measurement. 2. Size measurement. It helps in understanding the actual size of a city. That is the use or the uses of scale or the functions of scale. It allows you to understand the actual size of a city. The size of town A, or for instance Abuja, and the size of, let's say, Oyo cannot be the same. So note. It also shows the level of details, meaning large scale shows more details while small scale cover large area with less details. So scale allows the level of details on the map. Large in the sense that large scale map means the features are big, but it is for a small area. The features on the map are bigger and it cover a small area. while the small scale cover a large area and the features are less or small. Another functions of scale is navigation and for planning. Then another functions or uses, it control the amount of information that is to be shown on the map. Very important. The amount of information to be shown on a map. Then scale conversion. Note, as in the previous slide, I said when you are moving from centimeter to kilometer, you divide it by 100,000, and from centimeter to meter is by 1,000. Now, centimeter on the map, which is equals to 50,000. So what you need to do, you divide the 50,000 by 100,000, then you have what? You have 0.5 kilometer. We did this in the previous class. Now, if you are moving it or converting it, the kilometer to miles, you multiply. If you are converting the kilometer to miles, you multiply by 0.621. Then you have 0.31 miles. So you will do this as an assignment. You have to convert 100,000 centimeter, convert it to meter. Then the answer of 100,000 centimeters, you now convert it to miles. You also convert 50,000 to meters. That's an assignment for you. The one green, red, and hash. So do that. Next year, we'll be looking at how to construct scale. What we mean here, the bar scale or the linear scale. So step-by-step construction. What you need to do, one, you have to get the material needed or the instrument needed. The instrument needed, one is ruler, two, compass, three, pencil. When you have gotten these three things, now you start your construction properly. How do you do that? You draw the line, the segment line, you draw the line. Having done that, you draw an auxiliary ray on it. Then having done that, you mark equal interval on the ray using your compass. You draw a line, let's say maybe 10 centimeters or 20 centimeters. Then you draw what? Auxiliary ray across it. Then you use your pair of compass from the angle, let's say angle 30. You mark the segment in equal parts. So you mark equal interval on the ray. The marking will be on the ray equally. Then next, you connect the last point to B. Then you draw parallel line. This line will intersect A, B, dividing it into equal parts. That's assignment 2. So you have to do this. This is assignment 2. Then the next year, determine scale of a given map. How do you determine a scale of a given map? How do you know scale of a given map? One, look at a scale bar or ratio. The bar scale or the ratio, don't forget the ratio, the one will say 1:50,000 or 100,000 or what have you. Then you read it directly. You look at the scale on the map. That's how to determine a scale of a given map. So you read it directly. You say 1 centimeter represent 50,000, which means one unit on the map represents 50,000 of the same unit on the ground. Don't forget in the previous class, when you see a ratio, this a scale that is ratio, that two means they are in the same unit. 1:50,000 means one unit on the map is the same unit on the ground. That is to say, 1 centimeter on the map represent 50,000 centimeter of the ground. That is how to determine scale on a map or on a given map. Next is you pick two. This you pick two if you are to determine the distance. How to determine distance from a given map. One, you pick 2 points, city A and B, which distance you know, city A and city B. Having picking the point, so you use a ruler to measure the distance between those points. Use a ruler to measure the distance between those points. Having done that, record the distance on centimeter or inches or inch. Having done that, having picked the point, you record the distance on your worksheet. Then you calculate the ratio by doing what? Converting the real world distance into the same unit with the map. Then you use this formula: scale distance on the ground divide by distance on the map, which is 50 kilometer divided by 50 centimeter on which is on the map. So then we have 50 kilometer equals to 50 multiplied by 1000 because it's to meter. It's equals to 50,000 meters, which is same as 5 million centimeters. Having gotten the 5 million centimeters, you now divide it again by the distance on the map, which is 5 centimeters. Then you have it as 1 million. So the result, if you are asked to convert to statement or to RF, your result will now be 1 centimeter represent 10 kilometer as a statement, or as RF 1:1 million. That is how to determine the distance of a city, point A to point B on a given map. Next on it is large, medium and small scale map. How do you know large scale map? How do you know medium? How do you know small? How do you know that this map is a large scale map, this map is a medium scale map, this map is a small scale map? So large scale map shows more details And a good example of it is 1:2000. I said in the previous slide that large scale map shows more details, or the details are bigger but it cover a small area. So a good example of a map, when you pick a map and you see that the map is less than 25,000 centimeters, note that that is a large scale map. I said when you pick a map and the RF on it is less than 25,000 centimeters, note that that is a large scale map. So a good example is 1:2000 to 1:24,000. And another perfect good example of such map is what? Is cadastral map or plan. Next, we have the medium scale map. How do you know that this map is a medium scale map? It shows details, and the details are not too small and they are not too big. They are not too large and they are not too small. And the scale, when you pick a map and you see that the map is 1:25,000 or more, just note that that map is a medium scale map. That is 1:25,000 to 1 is to the range to 1:500,000. Note that that map is a medium scale map. And good example of such map are the topographic map and the administrative map. The topographic map is a map that covers large area, and the administrative map shows the boundary of jurisdiction or boundaries of wards, states, countries. So those are medium scale map. Then we have the small scale map. Small scale map cover a large area. The area small scale map cover is larger than that of medium. It's larger than that of large. So a small scale map covers a large area with less details. Good example of that is 1:500,000 to 1:1,000,000. And a good example of such map is world map or globe or atlas. World map, globe or atlas map. So those are good example of small scale map, in the sense that it cover a very large area. Don't be confused with the figures you see. So just know that any map you pick and it covers a large area, that the area is so wide, note that that is a small scale map. Then next, transferring of details from base information. How do you transfer details? This is manual way of drawing your map. Assuming, let's look at this scenario. You are to produce a map of Oyo East and you have existing map. The existing map serves as a base map. You have existing map of Oyo East. So the existing map serves as a base map. So what you do, you have that base map. Without your base map, you get a tracing paper or polyester. You place on the base map, you place it on that base map. You staple it down on your drawing board with your pen and ink, your drawing pen, which we call rotary pen. You start tracing out the feature that you need on your new map. Assuming you're looking for road, and you have a base map of Oyo and you're looking for road, you want to draw all the roads in Oyo town, or let's say Oyo East. You place your tracing paper or polyester on the base map which you have gotten maybe from the administrative office of Oyo East or from the local government. You place it down, you put another tracing paper or polyester on it, then use your pen and ink, you draw out the roads on the tracing paper or the polyester. In doing that, you have transferred details or you have transferred information from the base map to a new map. So this is a practical aspect in which you need to practice. So this aspect is manual way of drawing your map with pens and ink. Next, peck lines in relation to other details on map. Peck lines. Peck lines on a map is a type of line symbols composed of short broken segment pictures that are not physically present on the ground but are significant for interpretation or navigation or planning. The peck line, you won't see it physically on the actual ground, but it is used to interpret navigation or planning. It's very important, it's significant on the map. So a good example of it, how it is related. Relation to other map details. One example of it is boundaries. Boundaries are in peck lines. They are often used to indicate administrative or uncertain or dispute boundaries. Peck line note, it is used on the map to show administrative jurisdiction like boundaries. When you draw your map and the boundary of the map or the boundary of the area, let's say Oyo East and Oyo West, they are close and your interest is on Oyo East. So you use a peck line to demarcate Oyo East from Oyo West. That's what this is telling us, or that's what this means. So use peck line. Use peck lines to indicate boundary. We also use peck line for area that is under dispute, boundaries that are under dispute. Use peck line for it. Next, peck lines are also used to show footpath or drain. Peck line are also used to show footpath or drain. Also, peck lines are also used for supplementary contour. Ordinary contours are shown with regular lines, but for supplementary contours, peck lines are used. We also use peck line for something like surface features in geological mapping. Peck line can be it means underground utility, fault or projected tunnel. For geological mapping, if you use peck line, it either means it is for utility, that is underground utility, or there is fault beneath the geological findings, or for projected tunnels. That's how to use peck line. Now, having said that, let's look at how to enlarge and reduce our map or maps. Enlargement and reduction is a technique used in cartography to change the size of a map without affecting its proportional relationship. You can change the size of your map to either small or large, and its relationship with other picture will not be affected. Enlargement increase the size of a map but maintain its proportion. When you say I'm enlarging this map, it means you're increasing the size of that map, but its proportion must be maintained. This means that symbols, distance, and the likes are scaled up uniformly. That is, the symbols, it shouldn't be that you enlarge a map, the distance is large, and the symbols of other things, maybe like um city, is small. Both must be uniformly. And the reason for enlarging a map is to make smaller features to be visible. That is why, that is one of the reasons why maps are being enlarged, to make smaller features to be visible. Now, the method used for enlarging a map can use graphical method, also known as grid. The original map is divided into grids, and each grid is redrawn at a larger scale. You enlarge the map by using grid method. Another method you can use in enlarging map is photographic method, using tools such as pantograph. You have ever seen that, using tools such as pantograph. Then we have the digital method of enlarging a map, using one of the GIS software to do that. Next is reduction of map. Reduction of map means decrease decrease the size of a map while maintaining proportional relationship. Reduction means you decrease, as in the you decrease the size of the picture or the map, but its relationship must be maintained. The method is as that of enlargement. You use pantograph, you use grid, and or GIS software. Now note, some minor picture, when you reduce a map, some minor features or details may be omitted to maintain clarity. When you reduce a map, just have this at the back of your mind, that some features that are too small may be omitted so that the clarity of the map will stand out. Note this, have this at the back of your mind, that when you are doing that, reducing or enlarging, there are effects to that. So effect of enlargement and reduction, one of the effects is scale change. Enlarging increase the scale while reduction reduce the scale. You just note that. If, for instance, you are enlarging a large scale map, that is 1:5,000, it means that the RF, we have it as 1:5,000. The RF will be, for instance, maybe 1:2000. It will reduce to 1:2000. Then the details or the features on the map will be more bigger than before. When you're enlarging a map that is 1:5000, the scale now will now change to 1:, let's say, 2.5 or 2000. And in that map, the details will be more bigger. That is what it means. Another effect is generalization. Some features may be omitted or emphasized for purpose of what? Clarity. When you generalize, some features may be omitted or some will be emphasized or bigger. Another effect, symbol size. This, in manual method, symbols may need adjustment to match the new scale. Then another effect to that is distortion. There will be distortion if not done properly, if not done well. Distortion, if not done proportionally, distortion may occur, especially in digital or non-uniform transformation. So if not properly handled, it will occur on it. So having said this, note that when you are reducing or enlarging a map, there are consequences to it. So thank you for listening and see you in the next class.